Hey there. In this video, we're going to talk about conditional branching in an assembly program. We're going to be looking at YASM x86-64 assembly or AMD64 assembly within Ubuntu, but this will probably be a useful video if you're just thinking about how to branch in assembly in general. So for starters, I'm going to promote one of my favorite books, as I often do. This is a book that is free and open source. You can get a copy yourself. I did not write this. The author of this book is a genius. His name is Professor Ed Jorgensen, PhD. He made this whole book and released it under an open source license, so you can literally just go to his website and get a copy of this for free. You can use this to make yourself into an assembly expert. So I highly recommend this to everybody. Anyway, so I'm going to open up this book. I'm going to assume that maybe you'll get a copy or you're just going to follow along with what I'm doing on the screen. But I'm going to open this book and I'm going to go to section 7, which is entitled Instruction Set Overview. I'm going to double click it. So open the subsections. And then I'm going to click on 7.7 control instructions. And then under that, I'm going to click on 7.7.3 conditional control instructions. So that's a lot of subsections, isn't it? I love a book with a ton of subsections. It makes things so much easier to find. If you or someone you know is going to write a book, especially if it's technical, please use lots and lots of subsections. Anyway, so conditional control instructions. In my last video, we talked about the jump instruction, where we can just be sitting somewhere in our program and then just jump somewhere else, anywhere we want based on the label. So conditional branching or conditional control instructions are kind of the same thing, except they will decide whether or not to actually jump. They might fall through to the next instruction, or they might jump away to somewhere else. So conditional branching or conditional jumping, it basically kind of goes like this. Step 1, you compare two values to each other. They will probably be sitting in registers. And then step 2, you will use a conditional branching instruction or a conditional jump instruction. There's lots of synonyms for these, but basically in the regular jump instruction that I just talked about in the last video, you just jumped and it was only one thing that you had to do. But in this case, we first have to compare two items and then we'll issue the jumping instruction, because the jumping instruction will have to decide whether to jump or not based on the result of your comparison, which makes sense, right? Like if you're going to implement something that's like if, you know, I'll put like a EXPR for expression, then, well, the first thing that we have to decide before we jump either into the block of the if, or if we jump into the block of the else, is whether or not that expression is true, right? So that's kind of what the compare instruction is doing, sort of. In higher level languages like C++, it can get a lot more complicated than that, but you know, at a basic level, that's basically it. Okay, so we're going to do conditional branching instructions. Let me show you a few of those. Okay, so for starters, here's the compare instruction right here on page 126. I think it's actually 127 in the PDF, but basically, you know, 126. We do CMP followed by 2 operands. So if we want to compare, I don't know, let's say R12 with R13, that's how you would do it. Just a 2 operand instruction. There's no results that are going to get stored in one of these operands. Both of these operands are just for input. The result actually gets stored in a special register called RFLAGS, which we hardly ever use or look at in the most common assembly instructions and design patterns. We just kind of like let the RFLAGS do whatever it's going to do, and the compare instruction will fill that up. So imagine that you know, depending on whether R13 is like greater than R12 or less than, or they're equal, or something else is going on between the two of them, the compare instruction just fills up all sorts of flags defining the relationship between those two registers, or those two operands, R12 and R13. And then after the RFLAGS register is all set up, then the conditional branching instruction will sort of rely on RFLAGS in order to decide whether or not it's going to jump or not. Okay, so let's see. There are tons of conditional, well, not tons, I guess like half a page worth, but there are lots of conditional branching instructions we can use. The first 2 I want to show you, and after this, by the way, I'm going to write a sample program just to show you how it is in practice. But so the first one is JE, which means let's jump if the 2 operands were equal. So again, you know, we compare R12 and R13. Maybe I'll put RFLAGS as a comment up here. We'll say sets up RFLAGS, and then we'll decide like what we're going to do. Are we going to jump if they're equal to some label? I'll write some label here. So that means the JE instruction will look at the RFLAGS register and decide, did compare think that R12 and R13 were equal? If it did, then we'll jump. If not, execution will fall down to the next line. So I'll put a nope instruction here, just, you know, a non-operation instruction. So if they were equal, then we'll end up jumping to some label. And if they were not equal, we'll end up letting execution fall through to the nope on line 10. And same thing for jump not equal and all these other ones. But there are actually two different versions of some of these instructions that kind of seem the same. Like for instance, this one right here, JL, that means jump if the first operand was less than the second operand. And notice how JB is jump below. That jumps also if the first operand was less than the second operand. So what's the difference between these two? Let me get my pen. I love excuses to do my little pen now. Well, I've got my pen. It's working. Oh, I erased it. Okay. Okay. It's working. Anyway, so notice how jump less than and jump below are basically doing the same thing, but there's one difference. One of them works on signed operands and one of them works on unsigned operands. So keep this in mind. If you're comparing two signed integers, you want to use you know, this group up here of instructions. But if you're using unsigned integers or just, you know, bits, then you want to use this group of instructions down here. And you definitely want to know what kind of data you have that you're comparing. Notice though that jump equal and jump not equal, they don't really care if the operands are signed or unsigned. That's because if you want to check to see if two things are equal, you just look at all of their bits, and if all of their bits are the same, then you just say they're equal. You don't even care actually if it's a signed or unsigned integer, if it's a float, if it's a whatever. You just go, are all the bits equal? Or are at least one of the bits unequal? Then we'll say it's equal or not equal. That's it. So keep that in mind. For all of your jump instructions where you're trying to see if things are equal or not equal, you're going to definitely be using these, whether you're using signed or unsigned integers or floats or anything else like that. But when it comes to actually, you know, integers that are signed or unsigned, these are the instructions you use for signed, and these are the instructions, that you'll use for, what have I done? That you'll use for unsigned. I keep confusing the on-off button for the red button, is what I'm doing. Oh, okay, whatever, I guess we're done anyway. So keep that in mind. In this video, we're just going to be using the signed integer instructions because that's the example that I have set up. But just imagine you could very easily translate this to you know, unsigned integers or floats. Okay, so let's see. We've got jump less than. We've got jump less than or equal to. Then we've got jump greater than, and then we've got jump greater than or equal to. And when you combine those with jump equal to or jump not equal to, that's pretty much all of the comparison that you need. And if you want to do something much, much more complex, well, then you can just, you know, start stacking logic on top of logic and branching on top of branching to do something that's like, this is what I'm talking, like if you want to do this, expression and expression, or expression and then maybe like a nested expression, right? If you want to do something super complicated like we can do in a higher level language, you're just going to have to make a bunch of mini jumps or find another way to reduce your logic. But in this video, we're just going to be taking a very simple comparison. All right, so I think that's everything that I can show you inside of this book. Let's go to the code now. So here's a little empty code, source code, a page. I'm going to stick all my code inside of it. Another reminder that if you don't know how to write assembly at all, you should see my other videos because I'm not going to cover the basics of assembly in this video. If you want to learn how to make a makefile or compile or assemble or like do all the basics that I'm not talking about in this video, I've covered them all in my other videos up to this point. So for now, we're just going to focus only on conditional branching, conditional jumping inside of an assembly module. So I'm going to start off by setting up my data section real fast. I'm going to grab my solution here and I'm going to say paste. And again, you know, this is covered in other videos, but long story short, I'm just going to be printing out a bunch of strings while this program executes. So I'm going to announce that the branching test is going to begin, and then I'm going to ask the user for some input, and then I'm going to, based on whatever the user inputs, I'm going to just print out a message that sort of, understands what the user inputted. So if the user inputted something greater than 0, it's going to output that. If they entered something that was less than 10, it's going to print that. If they entered something that was equal to 5, it's going to print that. And then it's going to say we've ended the branching tests. Then I have like a CRLF. Again, all this stuff is explained in other videos, but we're just basically printing. So I'm going to start the text section of my program, which is where all the instructions are. And I'm going to say that we have an external function that I can call on. Again, this video does not cover a bunch of other extra stuff. I'm just going to show you how to branch. Just trust me when I say that this helps me easily print numbers and things, or I guess in this particular case, it'll help me input a number from the user. But for you, if you're trying to run this at home, you can just start hard coding numbers just to make sure that you can branch correctly, and then eventually work your way up to a library that can take input for you. Or see more of my videos in the distant future. I don't know, years from now. I don't know. I might release the library or some other stuff to the casual viewer. So now here's our entry point. Again, I mentioned that there's going to be other parts of this program that I'm not showing. So this is a hybrid program where a C++ driver actually will call on my cool function. So just imagine from somewhere else in the program, you're calling on the cool function. How do we know it's a function? Because it's a label called cool, and then it has a return statement at the very end. That's pretty much all we need to know right now. Let me get rid of that load. I don't know why I always have the word load in all of my things. I think I put it in there on an early example, and then I just kept copy pasting to my heart's content and never stopped. We mark the function cool as global so that other modules can call on it, like the C++ module that I'm not showing you. But if you're writing a pure assembly module, you don't really need to mark your functions as global. If everything's within the same piece of source code, it's totally fine. So then I'm going to make a function call to a function called branch test. So very quickly, before I actually add branch test, I'm just going to add another function that we're not covering in this video called CRLF. And long story short, all it does is it prints a new line in the terminal, and that's it. Like it's a convenience function. I like to be able to call CRLF and have a new line. Okay, so let's start our branch test function. So here's the signature. It is just branch test with a void in front of it. I'm going to put a RET to say that this is a function that we will return from. And I left myself a little note here saying that I'm going to use register R12 as the number that the user inputs. So that means I'm going to have to preserve that because you have to respect the ABI. And the ABI says that R12 is a callee saved register. Again, see my other videos if you don't know what I'm talking about. But I'm just going to preserve it in a section that I call the prologue, or that actually the book calls the prologue. I do that now though too. And restore it in a section called the epilogue. So we have prologue and epilogue. We can have a push pop pair, and then in between we can have the meat of our function. Okay, so for the introduction, I'm just going to write a few instructions that just print out a message. So we're going to print out that intro message, and then call CRLF to print a new line, and then return. So maybe actually at this point we could probably check to see if this program works by trying to run it. So let me say clear and make run. Okay, so now the driver just prints hello. The driver is elsewhere. And we get that welcome message that says begin branching test, and then the driver retains control after that. So let's do a goodbye message real fast. So we'll do our goodbye message. It's just another string that I'm printing. It's no big deal right now. But if I run the program again, you can see that begin branching test and end branching test. Okay. So far, we're not really doing branching yet. The next thing we need to do is ask for a number. So this is how I'm going to do it in my program. In your program, it might be different, or you might have a hard-coded number or something like that. So for now, just trust me when I say that I'm going to print a prompt, basically saying, could you please enter a number? And then the next two lines are going to be just calling on one of my custom functions that will input a number from the user. So the user can type at the terminal. And we will receive their number through REX, which is the return value register for integer return values. and we're going to store it in R12. So that's why I had to preserve R12, because I'm actually going to start, messing with the value of R12 now. Okay, so we ask for a number, and then we sort of don't do anything after that. If we run the program again, it's just asking for a number, and I can just like type some stuff and hit enter, and then the program ends. Nothing actually happens. We're building. So now let's ask ourselves, is the number greater than 0? So let me copy paste some code here. So right now, we've just finished inputting a number from the user, and we'll ask, is that number that they inputted greater than 0? So again, the first thing we do is we use a compare instruction, CMP. We give it 2 operands. The order doesn't necessarily matter. For instance, right now I'm asking, is R12 greater than 0? So I can do jump less than or equal to like a different branch, or I can jump greater than equal to if I switch the operands or if I had the labels in a different order. But I'm just choosing to say, let's compare the 2, and then let's jump if R12 is less than or equal to, which basically means not greater than, this label right here, which is just branch test after greater test. So I'm going to do a print statement right after that, and then I'm going to draw out what the code is kind of doing. So let me make a label here so this actually will compile. Whoops. I'm in the wrong window. Okay, there we go. So what am I saying here? Okay, do the comparison, and then if the condition seems to be satisfied, then we'll jump to this, which means we'll just say goodbye and then exit the program because we'll return to the caller. But if that condition was not satisfied, then we're going to end up executing this stuff in the middle. So think about this. This is kind of the idea. Let's see if I can remember how to draw this right now off the top of my head. Suppose we have like some sort of an input. I'll call this input, and then maybe the input is going to be, whether R12 and 0 are equal or greater than or whatever. So I'm just going to say R12 and 0. God, that's awful. I really need to practice this draw pad. I spend like a whole week practicing with a different draw pad, and then when I come back to this one, I'm even worse than when I started. So we come in and we kind of look at R12 versus 0, and then we will jump in one direction if that's not greater than or equal to, or less than or equal to, and we'll jump in another direction otherwise. So basically here we'll say jump less than equal to, so I'll say less than or equal to, whoops, maybe I'll do R12, I need to somehow adjust the pressure on this thing. R12 less than or equal to, and so this is sort of has to do with, this branching path that we take. Like if R12 was less than or equal to 0, then we'll take the right branching path, which will mean we jump to after. I'll just put the word after. We'll jump to the after greater test sublabel, and otherwise, if R12 is, sorry, I said less than or equal to, yeah, if R12 is greater than 0, then we jump to this other thing, which is going to be the fall through. So it's going to be line 96, but I'll just say, I'll say fall for fall through. Basically, the jump won't happen if it's greater than or equal to. So you could imagine if you wanted to reverse the logic so you can use a jump greater than instruction, you could, but I'm choosing to do it this way. And then both of those will eventually reach, let's see, will eventually, actually, yeah, the fall through instructions, those will eventually reach the after instruction. I'll say always here. And then the after instruction will just kind of like finish the program and exit and all that stuff. So if you think about the control path here, we have an input. We're looking at R12 with 0 with the compare instruction. And then we use a conditional branching instruction. So maybe I should write, what do you want to write here? Maybe I'll just put JLE up here, because usually the compare instruction and the conditional jump or branching instructions kind of, come as a pair. So both of these combined mean, let's look at R12 versus 0. And if R12 is less than or equal to 0, meaning if it will jump if we're less than or equal to the right operand, R12 less than or equal to the right operand. Then we go down this path on the right to the after label. If that is false, meaning R12 was greater than 0, then we'll fall through to this stuff right here. And then whether or not we actually fall through, we'll always end up at the after area, because we're either going to jump directly to the after area, or we're going to fall through, and then the fall through falls through to the after area anyway as well. Let me just show you that real fast. Oh man, I'm having a hard time with this. Okay, so let's pretend that R12 was indeed less than or equal to. So that means instructions are instructions are getting executed. We're going down and down and down and down and down. Once we see jump less than or equal to, if that's true, then we jump to the after label, which means we just kind of jump around this message. And so we're not going to we're not going to execute that code. So in the case where that is true, where it is less than or equal to, we're not going to execute those instructions. So we're not going to say their number was greater than 0. We're just going to simply say goodbye. However, on the other hand, if that is not true, meaning if R12 was indeed greater than 0, then we're going to fall through, because this jump less than or equal to instruction, it will only jump if the RFLAGS, if the comparison instruction thought that R12 was less than or equal to 0. If that's not true, if it's greater than, then instructions, the control path is just going to fall through. So that means we will actually execute these. And then when they're done, execution will continue to fall through to the rest. So that means we're either going to see a message saying their number was greater than 0 or not, based on whether their number actually was greater than 0. Okay, hopefully I explained that somewhat clearly. Now let's run the code and see if it works. Hopefully I didn't forget anything. This is kind of a partial program at this point. I'm going to add a bunch more stuff to it, so hopefully this actually compiles. Enter an integer 5. Notice how it says your number was greater than 0. And if I run it again and I just type 0, it does not say that it was greater than 0. If I run it again and I type like a -5, it also does not say that it was greater than 0. Type a huge giant number here, it'll say your number was greater than 0. You could probably type a number that was just absolutely huge and have it overflow. I actually don't know how many 9s I need to type. And I don't even know what the behavior is going to be. I don't know if it's just going to crash the program, because this also relies on my ability to input a number, which is happening in a different library. Let's see if that even works. Greater than 0. Okay, it probably overflowed and went to a very, very low negative number. So, okay, I guess at least I know my library will probably work, sort of. Okay, so let's go back to the code here and let's upgrade it. We know now how to check for jump less than or equal to. We're going to say goodbye right there. So now the next thing we should do is check to see if the number was less than 10. So after the greater test is going to be here. So again, the same thing, like we can just reuse R12 because we're not really modifying it and we're not calling, well, I guess even if we were calling a function, R12 is supposed to be callee preserved. So we're just comparing it and then maybe printing a message if we want to. And regardless, we're going to end up at 103, this after greater test label. So then we'll compare again R12 with the number 10. And we'll say jump if it's greater than or equal to branch test after less test. So I'm going to do like right here. So now at this point, we're saying compare R12 with 10. If it's greater than or equal to 10, then just skip over the message. So if it's greater than or equal to 10, then, wait a minute, wait. Yeah, if it's greater than or equal to 10, then skip the message. Otherwise, the message that is printed is going to say that their number is less than 10. So again, you could imagine a little diagram. You want me to write it out for you? I don't know. I think once is probably enough, but let me just do it again. We'll do input is coming in, and it's just going to be, comparing and then jumping greater than or equal to. The input is going to be where we're just looking to see if R12, how it compares to 0. God, the number 1 is awful. My entire penmanship is awful. Okay, one more time. I hope you're laughing at home. We'll do R12 and 10. And so that's just sort of what we're comparing with the compare instruction and then the jump instruction. And so if we go on the left, I'm going to say that's the fall through path again. And if we go to the right, it's going to be R12 greater than or equal to 10 is going to be along the right side path. And then here, this is going to be after less. I'll say the after label, the after less label. So if we fall through, it's just going to print a message. Maybe I should do another little bubble here that's just like print. How about P for print? P for print. It's going to fall through, and then it's going to print, and then it's going to go to the after label. So you can see that the print instructions are only reached if R12 is not greater than or equal to 10, which is the same thing as saying it's going to fall through if R12 is less than 10. And then after we finally get to the after label, then we're just going to do, the rest of the instructions. We're going to exit the program. We're going to say goodbye. We're going to do whatever. Okay. So say their number was less than 10, and then regardless, here's like the ending label that we were conditionally jumping to. Let's see if this works. Make run. So we'll enter 5. Notice how it says your number was greater than 0 and your number was less than 10. Let's do an 11, I guess. It says your number was greater than 0, but it does not say that our number was less than 10, because 11 is not less than 10. If I do a -3 here, it says that our number was less than 10, but it doesn't say that it's greater than 0. So we have like a lot of decisions that we could make, right? Like imagine if instead of just printing a message based on something happening, you could call a full function or skip a bunch of extra code, whatever you wanted to do. So I'm going to go to the next condition where we're going to compare R12 to the number 5. And we're going to ask, is R12 equal to 5? So this is going to be the jump not equal branch. And again, if you wanted to say jump if it's equal to the place where we say, and then maybe like right after that, fall through and just do an unconditional jump, you can. I just think there are less jumps if I do it this way. So here we're just going to print, your number was equal to 5. And so basically, if it was not equal, we should have another label here that allows us to skip that. So, all right. So same thing. I'm not going to draw the diagram this time, but basically we're saying, compare R12 with 5, and if it's not equal to 5, then jump to this label down here, which just means let's say goodbye and not actually say that their number was equal to 5. But if it was equal to 5, then this JNE conditional branch won't actually jump anywhere. Execution will fall through to the next statements, which is just printing the message that their number is equal to 5. And then when that's done, it'll fall through to this other label and eventually fall through to the return statement. So let's see. I think that's actually like the whole thing already. Nice. That was easy. Let's do another run. And let's enter the integer 1. It says 1 is greater than 0 and 1 is less than 10. Greater than 0 and less than 10. Is there any way I can get nothing to print out? Greater than 0 and less than 10. You don't think I can do it? Let me try it. 9, no. Why did I even put 9? Okay, yeah, it's always going to say 0 or 10. Okay, so let's do a 4. We'll get both of those, greater than 0 and also less than 10. Let's do a 5. Now we should get all those messages. Your number was greater than 0. Your number was less than 10. Your number was equal to 5. And if I just do a 6 in there, again, it doesn't print your number was equal to 5. We have to enter an actual 5 for that. So that's the basics of conditional branching. Oh, there's one other thing that I wanted to make sure to tell you. I mentioned this in my previous video where we only talked about jumps. Bear in mind that these conditional branching statements or instructions, JE, JNE, all these things, they have a limited range of jumps of where they can jump to. So if you have a gigantic program and you're trying to jump very, very, very far away based on a condition, you might have an assembler error where your program won't even compile, won't even assemble, telling you, I think the message is, I wrote it down somewhere, jump out of range coming from the assembler. That basically means that these instructions can only jump about 128 bytes away from whatever instruction they are at, or whatever memory location they are at. So, after your assembler assembles your program, and after your linker links your program, and you just have like a binary, if you were to inspect all the instructions inside of your executable, your binary, you would see that they have offsets, right? You know, like one instruction is basically 8 bytes away from the one that comes right after it, but some instructions are a lot further away. So if you're trying to jump to an instruction that is more than 128 bytes away, it won't work. You'll get that error. So how do you solve that problem? Well, maybe I'll just write this down real fast. I'm not going to make this part of the code example, but just imagine we have, you know, jump equal to some label. And maybe I'll do a comment, very, very far away. And here's the label, some label, right? So if your assembler says, hey, you can't jump to some label because it's too far away, it's a jump out of range assembler error, then basically you can just make some other labels here. You can say short jump true and short jump false. You know, just make up some sort of a label and basically say, if it is, false. Yeah, okay, I guess this is the way I'll do it. This is not super efficient, but instead of jumping to the very far away label, in the case of true, you can just jump to the true label. So I'm going to say jump to the short jump true label. Otherwise, if it's not true, I'm going to just do an unconditional jump to the false label. So now you're definitely jumping in either case, and both of these labels are close by. So then I can pretty much just have the close by true label do an unconditional jump to some label. And that overcomes the limitation of branching instructions. So, you know, JMP, the regular jump instruction, it has an unlimited jump that it can do. It can go just to like very, very, very far away instructions. So that overcomes it. And then for the false, you know, I don't know, do whatever you want and then jump wherever you want. It doesn't really matter. I'm just trying to show you that if you make a short jump to a label that will only have an unconditional jump, so it's sort of like two jumps, you know, like a short jump and then a long jump, then you can overcome that limitation. Again, bearing in mind that some label is supposed to be very, very far away and sort of unreachable. Okay, so let me just double check that I talked about everything that I wanted to. We looked at the branching instructions, the signedness. I drew a diagram for you. We solved the jump out of range error. Okay, so I think that's basically it. Hopefully you feel like an expert now at conditional branching and how to make decisions. In future videos, I'll talk about how to implement an if-else block and how to implement loops and all that stuff. But for now you know that your program can make decisions in YASM x86-64 assembly. And conceptually, you can apply this to other assembly languages too. So thanks for watching my video. I hope you learned a little bit of stuff and had a little bit of fun. I'll see you in the next video. Hey everybody. Thanks for watching this video again. From the bottom of my heart, I really appreciate it. I do hope you did learn something and have some fun. If you could do me a small little favor, could you please subscribe and follow this channel or these videos or whatever it is you do on the current social media website that you're looking at right now. It would really mean the world to me, and it'll help make more videos and grow this community. So we'll be able to do more videos, longer videos, better videos, or just I'll be able to keep making videos in general. So please do me a kindness and subscribe. You know, sometimes I'm sleeping in the middle of the night and I just wake up because I know somebody subscribed or followed. It just wakes me up and I get filled with joy. That's exactly what happens every single time. So you could do it as a nice favor to me, or you could troll me if you want to just wake me up in the middle of the night. Just subscribe and then I'll just wake up. I promise that's what will happen. Also, if you look at the middle of the screen right now, you should see a QR code which you can scan in order to go to the website, which I think is also named somewhere at the bottom of this video. And it'll take you to my main website where you can just kind of like see all the videos I published and the services and tutorials and things that I offer and all that good stuff. And if you have a suggestion for clarifications or errata or just future videos that you want to see, please leave a comment. Or if you just want to say, hey, what's up? What's going on? You know, just send me a comment. Whatever. I also wake up for those in the middle of the night. I wake up in a cold sweat and I'm like, it would really mean the world to me. I would really appreciate it. So again, thank you so much for watching this video, and enjoy the cool music as I fade into the darkness which is coming for us all.